Hello folks, welcome to EvolvNext, and in this video we will have a look at what is descriptive statistics. Along with that we will also have a look at its different measures. Now before jumping into descriptive statistics, what is statistics? So it's a branch of mathematics that deals with collecting, organizing, analyzing, interpreting and presenting data. Statistics is divided into two types, that is descriptive statistics and inferential statistics. Descriptive statistics summarizes and describes features of a particular data set with different measures like central tendency, measure of dispersion, measure of shape, which we will have a look at in detail in a short while. And in inferential statistics, it uses just a sample of particular data. That is, if you want to make some analysis on a population of India, it will take a sample of that population and predict about the whole population. So let's jump in to the measures of descriptive statistics, that is measure of central tendency. Central tendency, measure of dispersion and measure of shape. The first one we look at is measure of central tendency. So measure of central tendency are statistical values that describe the center or a typical value of a data set. That is, mean, median and mode are the measures. Now mean is something that we are used to calculate since our school days. Median is nothing but a middle value of a particular data set, and mode is the most frequently used value in the data set. So let's have a look at it one by one. So if I calculate the mean, and I have some house prices, like the first house price is 3,50,000, then 4 lakhs, 3,80,000, 4 lakhs 20,000, 3 lakhs 90,000, 8 lakhs, then 4 lakh 10,000. So I've taken around 7 house prices. So to take a mean, I will have to divide this by 7 and I will get answer somewhere. This is not 0.7, this is 7. Okay, so I just can delete this 7, and the answer I would get is 4 lakhs 35,714. So does this reflect the typical price of a particular house in that area? So for let me calculate median for all this, the same data, that these 7 points. First you need to arrange them in order, that is, you need to sort them, you need to arrange them in order and find out the middle value. So there are total 7 values, that is 1 2 this one 1 2 3 4 5 6 and 7. So if I arrange this in a particular sorting order, that is in ascending order, I will first write 3,50,000, then 3,80,000, three lakh 90,000, 4 lakhs, 4 lakh 10,000 and so on. Okay, so I would arrange all these 7 items in a particular order. However, after arranging, if you notice, we will get let me just complete this one so that there is no confusion. 4 lakh 20,000, then it's last one, that is 8 lakhs. Okay, so if you look at this, there are total 7 values. The middle value is the fourth value, that is 4 lakhs. So the median would turn out to be 4 lakhs. Now if you look at the mean and median, there is some difference. However, as there is 8 lakh, which is drastically very high value than all the other values. All the other values, if you look at it, they revolve around 4 lakh. However, 8 lakhs is drastically different. So in this case, mean would not predict not predict, mean would not reflect the actual typical price in this area. So in these cases, median would be the more appropriate measure to calculate the typical price in that area. All right. So in this case, where we have taken 8 lakhs in data, the 8 lakhs data is called as an outlier. So mean is you can say not good when there are many outliers in your data. It may give you it may not reflect the typical price, and that's the reason we use median. Now let's move on to the next one, that is mode. Yeah, before moving on to mode, there is one more thing I would like to highlight, that is, if there were, now you may say, Vishal, okay, these are 7 values, you took out the middle value. What if there is even number of values? Then what we have done, say we had one another value, some value, I would write here 3 lakhs 40,000 or something. Then I would have taken mean of middle 2 values, this one, to find the median of this particular data set. That is not the mean. I would take middle 2 values and divide it by 2. So 4,000, in this case median would look like 4 lakhs plus 41000 divided by 2, and whatever the result you would have got, that would have been the median. So this solves the dilemma, what should we do in cases of even number of values in a particular data sets. Now let's move on to the next concept, that is mode. Let me delete this first. Yeah, so what is mode? That is something that we will see. Say you have a data set X, it has got this 2, 3, 2, 4, 2, 2. This is your data set. Now here you would see that 2 appears 3 times, and maybe we will add some more here, 3, one more time. 2 appears 3 times and 3 appears 2 times. So in this case 2 is the value that appears maximum times. Then the mode becomes 2. If say 3 would have appeared for 3 times, then that would have been bimodal. Then the mode would have been 2 as well as 3. Alright. So now why are we using this kind of why we are using this kind of measure? Suppose we have this data set X is equal to 2, 3, 2, 4, 3, 2. Alright, this is nothing but it represents the number of bedrooms in that particular houses that we were having a look at earlier. So you would see here number 2 has occurred 4 times and number 3 has occurred for 2 times. So we can easily say in this area there are more 2-bedroom apartments. So whenever you will a particular sales is to be done, the 2-bedroom apartment will be promoted. Alright, so that is the main goal to have this measure called as mode, and it mainly works well with the categorical data. So you would see normally mode works well with categorical data, mean with continuous data, or you may say symmetric data, and median is good for skewed numeric data. We will see what is skewness when we discuss about the measure of shape. So let's move on to the next section, that is measure of dispersion. Measure of dispersion tells us how spread out or scattered the data values are around the center. So to measure those values, how are they spread out? There are 4 different measures: range, variance, standard deviation, and interquartile range. So what is the range? Range is nothing but it will give you a quick estimate of total spread, that is the highest value in the data set minus the lowest one in the data set. Variance, it measures the average square deviation from the mean, means it will take the square differences from the mean, whatever it is, and this is the formula for population and sample. You might not be aware of the term population and sample, however, just to give you a little insight into it, we are not looking into it in detail, but little insight. For population, you may consider the population of India, and for sample, like you may consider a particular area or a particular state population. All right, so we have different formulas to calculate variance for population and for sample. Here we will be looking at calculating it over the entire population, because we will be taking a limited values data set. All right, a standard deviation, it describes that how much variation or dispersion exists from the average, that is the mean. So it describes average distance from mean in original units. When we calculate variance, we square the differences. That's why we don't get the difference in average distance in the original units of the data, but to get that we have to take a square root again, and that's nothing but standard deviation. And what is interquartile range? It helps to detect variability and outliers in the central data, that is the spread of middle 50% of data in a particular data set. So this is just a theory about measure of dispersion. Let's see with an example and calculations. We have a data set that is 50, 52, 53, 55, 56, 58 and 95. So the first measure of dispersion, that is range. How do we calculate range? Simply the maximum value and the minimum value you take and subtract minimum value from the maximum. That is, range here would be equal to 95 minus 50 is equal to 45. Okay, then next we have is standard deviation and variance. As we have already seen, how do we calculate standard deviation? We have the formula, right? This one, square root of variance. Okay, so first you will have to calculate variance and then standard deviation. So let's calculate variance first. That is, for the population it is denoted by this, and is equal to summation of all the data points, in this case all these data points, xi minus mean square upon n. Okay, so to calculate this, first you will have to calculate mean. If you calculate mean of all this, that is 50 plus dot 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 all this till 95 upon how many values are there, 8, you will get is it is equal to 473 by 8, and that is 59.125. somewhere this value you will get. And when you do a calculation for this thing, that is when you subtract in the sense when you subtract a value, that is xi is what, first one is what, 50, right? This one 50 minus mu was what, 59.125. okay, I don't need to write this, square of this plus, then what is next, 52 minus 59.125 square. So if you do all this all the way till 95 minus 25 square, if you were going to do this and divide this by n, that is 8, you will get a result as 189.2. and if you take a this is nothing but what, it is a variance. Now if you want to find a standard deviation, you also know you take a square root of 189.2, which approximately is equal to 13.75. so 13.75 is nothing but the variance that I have calculated. So we have seen the three measures of dispersion. First is range, then it's a variance, and then a standard deviation. Now in the same data, we will calculate the interquartile range. Okay, we have seen the definition already. So let's calculate the interquartile range. Yeah. Now for this data, if you sort it first, it will be the data is already sorted. Then you would look for Q1 and Q3 to calculate interquartile range. Q1 and Q3 are nothing but quartile 1 and quartile 3. So we need to first divide this data into quartiles, and let's see. Here you would easily see this is the middle point, this is the median. Okay, so somewhere 54.5. As I mentioned earlier, when you calculate median for even number values, you will add these two and divide by 2. So 54 plus 55 divided by 2 is 54.5, and this is your 50%, exact 50%, exact middle point of your data. So this is the first half and this is the second half. So if I want the value of Q1, that is 25% of data, what I will have to do is I will have to add these two. I will have to calculate median of these 4 points, and that turns out to be 52.5, and Q2 turns out to be 56 plus 58 by 2, that is 57, and IQR is calculated by Q3 minus Q1, that is equal to 57 minus 52.5 is equal to 4.5. Alright, so the spread of data, the middle spread of data is calculated by Q3 minus Q1. Okay, to explain this concept, I would just show it to you. See, suppose this is your entire data. This is your entire data. Okay, and this is your 50% mark. Okay, so this is say your Q2, that is the midpoint of the data. This is your 25% of data, this is your 50% of data, and this is your 75%. Now what we are looking into when we go for interquartile range, we look for this part of data, that lies between 25 and 75, 25 and 75%. Okay, this part of data, this part of data. That's why we subtract Q3 minus Q1 and we get this result, 4.5. Now how this interquartile range is useful? So with this we can easily detect the outliers in the data, and we have formula for those. Alright, so to detect outliers we need to know what should be your lower range and what should be your upper range. So let's calculate the lower, and what is the lower boundary. So lower boundary is given by Q1 minus 1.5 into Q3, into the IQR that we calculated, that is 4.5, and this turns out to be 45.75. Alright, so this is your lowest range. Anything below this will be considered as outlier, and upper bound is equal to Q3 minus 1.5 plus 1.5 into 4.5, that turns out to be 63.75. Okay, this is the upper bound. Any value beyond this is an outlier. So in our data set, if you look at it, if I define outlier, outlier is any value which is less than 45.75 and or greater than 63.75. In our data set, there is only one such value, that is 95. So 95 will be detected as an outlier using this IQR calculations. So this is how the interquartile range plays an important role to detect an outlier from a particular data, and also tells you where the majority of data, that is the middle 50%, lies and shows you the spread. So to show this, we actually draw box plots while doing visualizations, just as an FYI. Okay, now let's move on to the next topic, that is measure of shape. What is measure of shape? It describes the distribution pattern. Just a theory again. It describes the distribution pattern of data set, that is how the data values are spread around the center, how the data values are spread. Now it is not saying about the distance anymore, it is saying how are they spread and whether the shape is symmetrical, skewed or flat. Means in this measure of shape there are two measures, that is skewness and kurtosis. So in skewness, it will tell about the asymmetry of the data distribution around the mean. Means is the data rightly skewed, leftly right skewed or left skewed. So that is does it have tail on the right or left? Yeah, when we see it graphically, you will be able to understand what I'm trying to say. And whether the data has the peakedness and the tailness around the distribution, where to describe that there is a measure called as kurtosis. Okay, so kurtosis describes the peakedness and the tailedness of the distribution. The formula to calculate the skewness and kurtosis for population is given here for the skewness in this table. If you look at this formula population, and after calculations, how do you interpret that particular data is right skewed or left skewed or whatever? Okay, so let's have a look at the skewness calculation. Say data is this one, 2 3 4 5 6 8, that is represented by x in this scenario. First we calculate the mean, then we calculate all these things, that is in step 2, because we need to replace in the formula for skewness. All right, and these are all the calculations that we do. Then we calculate the variance and standard deviation. At the end of it, when you replace, if you look at in the step 3, last step, when you replace all the values, you get 0.88. So what would you say or comment on the skewness of this particular data is that 0.88 is greater than 0, so it is right skewed data, is what we can comment. And then next is kurtosis. Again, the formula is there with us, and again we calculate. I just took the snapshot of the calculations that I made, so that we save some time doing all these complex calculations. So I got the standard deviation as 98.48 for our data, and when calculated the kurtosis, I got it as 10.24. Then we calculate excess kurtosis, that is with this formula here. If you would see here, yeah, excess kurtosis is calculated, kurtosis minus 3, and that turned out to be 7.24. So if the excess kurtosis is greater than 0, then we can say that the data is having heavy tails, that is leptokurtic. The data is leptokurtic. So this is how it would look like. You see this faint pink curve, that is how our data would look like in the case of leptokurtic. There are three types of kurtosis: mesokurtic, leptokurtic, and platykurtic, and these are the graphs for those, how they look. And for mesokurtic, normal peak and tails, like a normal distribution. Okay, that is bell shape, middle one. Then for the leptokurtic, as for our data we discussed, it will have sharp peak and heavy tails. And for platykurtic, it will have fewer extreme values, flat peaks and lighter tails. Now if you see over here in the another diagram, we have negatively skewed, positively skewed. So towards the left, there whenever there is a heavy tail, then that's a negatively skewed. On the right, if there is a heavy tail, then that is positively skewed. And normal skew is where you don't see asymmetric distribution. It is perfectly symmetric distribution of data. That is what we say that there is no skew. So that's all for this video. We will meet in the next session. Thank you for watching. Have a nice time.